So in the prior video, we introduced the inverse trig functions, talked about notation a little bit. In this video, I want to explain how to use the unit circle to find an answer that's a little bit trickier to determine. So what we're going to be doing is trying to solve the equation that you see right here. So cosine of x is equal to the negative square root of 2 over 2. We want to assume the solution is between 0 and 180 degrees. Your problem may or may not be specifying that. As we introduce this, our problems will say that. Eventually, it's going to be on us to try to figure out which answer it is that we're going to be looking for. We'll talk about why there's really more than one answer to this once we start seeing some of the stuff that we're going to be looking at on the unit circle in just a few seconds. So here's what you can do if the calculator is in play. You're solving this for x. The x is inside of a cosine function. If you apply inverse cosine to both sides, you end up with cosine and inverse cosine undoing each other. That isolates x. So if you just take inverse cosine of this negative fraction, you're going to get the appropriate answer. So if the calculator is in play, double check the mode. We're still measuring in degrees, so yeah, I'm in degree mode, so I can get out of that. I'm going to do inverse cosine. Move off to the side a little bit so you can see what I need to type in. Oh, why am I docking over there? I guess I can't show you that. I'm going to do inverse cosine of this fraction that you see right here. So negative square root of 2. Now that's it for the square root. So if you're using a TI-83 as I am right now, you're going to have to be careful with your grouping symbols. So that's the end of what's under the root, and then I have to divide by 2. And I'm going to close that initial grouping symbol that it gave me when I chose the inverse cosine. And there we go. I get 135 degrees. So if the calculator is in play, this is not that difficult to do. What if the calculator is not in play? What if your answer wasn't supposed to be between 0 and 180? We want to talk about those situations with the unit circle. So here's what I do. I think about my 30-60-90 ratios, my 45-45-90 ratios. We got another video where we introduced those. Those ratios are going to be the things that we utilize in order to kind of push us in the right direction, at least initially. So for 30-60-90, it's 1, 2, square root of 3. For 45-45-90, it's 1, 1, square root of 2. There is a square root of 2 in this ratio. So that hints me in on the fact that I'm going to be using a 45-45-90 triangle. The ratio for a 45-45-90 triangle is 1, 1, square root of 2 for the biggest side, and that would be the hypotenuse. But if I'm drawing a 45-45-90 triangle into the unit circle, I need the hypotenuse of that triangle to be equal to the radius of the unit circle, and the radius of the unit circle is 1. So I have to divide all sides of that triangle by square root of 2 in order to squeeze my 45-45-90 triangle down to a point that it'll fit into the unit circle. So I've got my 45-45-90 triangle drawn into the second quadrant. Why did I draw it in the second quadrant? Why didn't I draw it in the first quadrant? Normally, whenever I'm thinking of 45-degree angle, I would be looking at an angle that opens up from the positive x-axis. So why in the world did I draw it over here? So think about what we've said about the unit circle. We're looking for when cosine of an unknown angle equals this fraction. Cosine corresponds to which coordinate from a point on the unit circle? The x-coordinate or the y-coordinate? And hopefully you're going to agree, based on our prior discussion, it's the x-coordinate. So I need my x-coordinate from the place where I draw my triangle to end up being negative. And I need my x-coordinate to not only be negative, but to be this value, square root of 2 over 2. So I drew my triangle in the second quadrant because clearly in the second quadrant, I'm staying between 0 and 180, right? I'm going to an angle that's between 90 and 180 if I'm looking at this angle right here. I need my x-coordinate to be negative, right? So let's think about this. What is the relationship between this fraction that we see here and these other sides? Because right now, the one thing that kind of seems like it's missing is the fact that I don't have this fraction, square root of 2 over 2, as any of the sides of this triangle. But if you think about how you can simplify this, notice that this fraction that you see within our equation does not have a root in the denominator. The fraction that we see down here Definitely does. If I multiply this fraction by square root of 2 over square root of 2, if I rationalize this denominator, what I'm going to end up with is I'm going to end up with square root of 2 in the numerator, square root of 4 in the denominator, square root of 4 definitely goes down to a 2. So although it doesn't necessarily look like the triangle that I've drawn and the way that I've labeled the sides gives me an x coordinate of negative square root of 2 over 2, this value really is equal to square root of 2 over 2. So let's kind of connect the dots here one more time. We drew a 45, 45, 90 triangle because 1, 1 square root of 2 is the base ratio. We had a square root of 2 in this fraction that cosine was equal to. We drew our triangle in the second quadrant for two reasons. We wanted to be between 0 and 180 degrees. We needed cosine to have a negative answer. Cosine corresponds to the x coordinate from a point on the unit circle. Therefore, we drew our triangle into the second quadrant. If this is a 45, 45, 90 triangle, that's 45 degrees. The angle that's plotted in standard position here is actually this larger angle. If that's 45 degrees, that's 45 degrees shy of a full 180 degree opening from the positive x-axis. And if I take 180 minus 45 degrees, there's that 135. So the last thing I want to say about this, and then we'll close out this video and do a couple other examples, is why knowing our answer had to be between 0 and 180 was significant. If I were to go further around the circle, I could have drawn my triangle down here in the fourth quadrant, or excuse me, the third quadrant, that would be. You hopefully agree with me that my x coordinate is the same at this location and the location I'm now at down here on my unit circle. This answer is past 180 degrees. So eventually we're going to discuss these issues known as principal values. For a cosine or an inverse cosine principal value, we're always looking to give an answer between 0 and 180 degrees. But there's more than one answer here. There's more than one spot, more than one angle I can specify on the unit circle that gives me this x coordinate. As long as I'm either here or I'm here, I have this as my x coordinate from the circle. I can give a negative angle if I'm opening downward through the fourth and then the third quadrant to get to that point I just plotted. There's a negative angle that satisfies this. There's an angle that's a little bit past 180 if I open up from my standard position angle in the positive direction down to this angle I just showed. So you're going to need to know where your answer is supposed to come from. Right now that's specified. Eventually it won't be. Hopefully you understand why there's more than one answer to this problem and why this statement right here was significant.